Basically, a language model is a probability distribution over strings of text. So if you have a vocabulary of some sort, maybe an English vocabulary, different combinations, strings of words in that vocabulary are sentences, and the language model is basically a black box that is going to assign numbers, probabilities, to different strings, and those probabilities reflect how often you expect to see that string in a language that you're working with. So, for example, if you're working with English, and these are the 4 strings that you're concerned with, a language model would assign some probabilities to those strings. So, and hopefully it would assign a pretty big probability to string 1, a quick brown dog, because that is it's an English snippet, and it is well formed and it's grammatical. It's a kind of thing that you would expect to see in English. String 2, dog, quick, a brown, is all English words, but it's not very grammatical, so you would expect a lower probability for that. String 3 is half French, but it does have some English words, so you would expect some probability of that occurring in English, and something like that you would not expect to see in English a lot. So you would expect the probability for string 1 be greater than 2, 3, and 4. That, of course, is for normal English, and those probabilities will depend on what exactly it is, what exactly language you're trying to model. In fact, for almost everything that you do in IR, there is no difference between strings 1 and 2. Right? We always, if we don't assume word independence, we assume exchangeability, which means that the ordering of words has no meaning whatsoever. So strings 1 and 2 would be extremely unlikely. And if you're working in cross-language IR, then string number 3 is actually something that you want to be a kind of a string that you might want to assign high probability to.